Hey guys, before jumping into the nitty-gritty, a little bit about me. I'm Sean. I'm in the software engineering industry for about 14 years. I'm currently a technical lead at Tiger Spike, leading engineering teams and delivering solutions for our customers. In this talk, I'll explain how we used AWS Amplify along with AppSync and other AWS technologies to deliver a mobile application for one of the largest energy provider, Energy Queensland. Let's start with project goals. We wanted to get the MVP out in the hands of our customer quickly. That would integrate with Energy Queensland's internal user management system. Due to the nature of the application, we had explicit requirements for supporting offline capability in case of no network coverage. We wanted to establish a framework which was scalable and could be built upon and ticked all the data, audit, and compliance requirements. We needed an accelerator that would allow us to achieve these goals, and AWS Amplify seemed to be a perfect choice. This is a very simple diagram of a high-level solution that we had for the MVP. We used AWS Amplify with AppSync and GraphQL, used DynamoDB for data storage, AWS S3 for file storage, and used Cognito to integrate with EQ's internal user management system. We also used CloudWatch for logging and monitoring. Let's start with Amplify CLI setup. AWS Amplify CLI comes as an NPM package, and you need Node version 10 and above and Node Package Manager version 6 and above to install the CLI. While working with the Amplify CLI, you need to make sure that you have an AWS account and your AWS config and AWS credential files are set up correctly to indicate that which AWS account is going to be used while setting up the resources for your backend. You can also use Amplify configure command to set up the credentials. Once you have configured the CLI, you can start with Amplify Init command. Let's go to a quick demo. So here, let's start with Amplify Init command, and it is going to ask a series of questions. Let's start with the name of the project. You can configure multiple environments within your Amplify application to have dev, non-prod, and prod environment. We are going to name this environment as dev. I'm just going to choose none as the default editor. We are working with an iOS application, so we'll choose iOS. I have different AWS profiles set up on my machine, as mentioned in my previous slide. So I am going to choose default. I'm going to choose yes, and then I'm going to choose default, which is going to my personal account. This will take some time and initialize AWS Amplify backend. Once it's initialized, you can see it on the AWS Management Console like this. Now that we have set up our Amplify backend, let's add an API to our dev environment. We can use Amplify Add Api command to just do that. Let's go to the terminal and run the command to add an API. Before I start, I have put GraphQL annotated schema file in this directory, which I'm going to use while API generation process. I will explain shortly what this is about. Let's run Amplify Add Api command. It is going to ask a series of questions. We're going to choose GraphQL as a mentioned service. We'll provide an API name. In order to secure your API, you need to choose an authorization type. Amplify provides multiple options, and we can choose the one which suits us best. So for now, we're just going to go with API key. We're going to just use sample description, add the expiry days. I am going to choose yes because I want to use my schema, which I've just mentioned here, as part of the API. So I'm going to select yes. I want to make additional changes. I'm not going to use additional auth types. We will be using conflict detection if we are going to use offline capability. For now, I'm just going to choose no. So this I'm going to say yes because we want to use the schema that I have in my directory. And I'm going to just use. So as you can see that Amplify Add Api is successful, and I can actually use Amplify status to see that an API has been generated. Now, it has not yet been pushed to the Amplify to the backend, to the AWS backend. In my demo, I used an existing GraphQL annotated schema file while setting up the API, which looked something like this. So what is GraphQL? GraphQL is a query language for your API and a server-side runtime, which is AppSync in our case, for executing queries by using a type system you define for your data. You can use types to describe your data. You can use mutations to create, update, delete the data, and then you can use queries to ask which specific data you're after. You can learn more about GraphQL by going to the link that I mentioned below. As I mentioned just now, the GraphQL schema consists of types, mutations, and query definitions, but you don't see any query or mutation-related information in this schema. Instead, you can see these directives. Each one of these directives has a purpose and contributes to generating the actual GraphQL schema, AppSync resolvers logic, the data source, which is DynamoDB table in this case, and specific indexes and keys on that table. The API which we have just created is still sitting in our local environment and actually have not yet been pushed to AWS yet. We will use Amplify push command to push the API. Let's do that. This is going to ask for confirmation that it is going to create an API, which is safety-checked app. We're going to say yes. CLI is asking if we want to generate the Swift code for the newly created GraphQL API. We're actually not going to use this, the code which will be generated by this command, because we are going to use the Amplify libraries, Amplify code gen libraries. So we are going to say no. Now, it will take a couple of minutes to generating all the resources, because it's going to use, it's going to generate IAM roles, AppSync APIs, DynamoDB tables, indexes, and all the resolvers. Let's talk a bit more about the directives. So when you use add model directives with a type, it generates a DynamoDB table, the IAM roles, create, update, delete mutations, and input objects related to that type. It also creates the list and get queries and associated filter objects. It allows you to skip the boilerplate code for your simple CRUD operations for the type, and also automatically generates the AWS resources which I've just mentioned. It then attaches the generated DynamoDB table as a data source with the AppSync API. Add auth directive allows you to manage different levels of authorization on your GraphQL types. It adds relevant logic to your AppSync resolvers that manage the authorization while running mutations or queries. This particular example adds logic to the resolvers to make sure that the specific type has owner-only access, which means that only the person who created object can retrieve it. Add key directive is used to create partition key on the DynamoDB table. You can use additional key directives to create secondary indexes on the DynamoDB table. The fields property defines which properties will be used as a partition key and sort key for the index. In this particular example, we are creating a global secondary index with owner as a partition key and a composite sort key with status and created at fields. Once we generate and push the API, the final GraphQL schema looks something like this. As you can see, it has query objects, mutations, inputs, and connection objects created automatically. Now that our APIs are ready, let's integrate it with our mobile application. There are two ways we can integrate with Amplify backend that we've just created. One is called Amplify libraries, which are open source client libraries that provide use case centric, opinionated interfaces to connect with the AWS backend. The other one is AWS Mobile Sdks. AWS Mobile Sdks provide a lower-level interface to connect with the AWS backend. When we delivered the Energy Queensland project, Amplify libraries were in preview. That's why we decided to use the AWS Mobile SDK. But now Amplify libraries are generally available and are recommended way to go. In the coming slides, I'll be showing the difference between the two interfaces and will be showing a demo with Amplify libraries. There are still some use cases where you will have to resort to using the AWS Mobile SDK, and Amplify libraries provide escape hatches which you can utilize to implement those use cases. You can see Amplify CLI provides API code generation for both SDK and libraries. You can use the specific CLI command based on which option you're going for. You can see on the right-hand side, Amplify code gen command is going to generate a single API.swift file which will work with the mobile SDK, or you can use Amplify code gen models, which is going to work with Amplify libraries, and it's going to generate specific models for that. You can see how CRUD operations are different between the two interfaces. AWS Mobile SDK provides low-level GraphQL interfaces, while Amplify libraries provide a nice model wrapper for the CRUD operations. You can see the same for update and delete operations. And the same goes for query operations. If you have been using GraphQL before, AWS Mobile SDK interfaces will sound more familiar to you as compared to Amplify libraries. Now let's jump to a quick demo and see Amplify libraries in action. Let's run the Amplify code gen models command to generate the models based on our GraphQL schema, which we are going to use in our iOS project. The model files are generated successfully, and they are available in this directory. Let's jump to the Xcode project to use them. This is the Xcode project, which I've created in the same directory where Amplify config files and model files are available. I have added the references of the models which are generated by the command, and you can see here. I've also added Amplify configuration.json and AWS configuration.json file, which is going to be used by the Amplify libraries to connect with our backend. We've used CocoaPods, which is the dependency manager, and to integrate the Amplify SDKs, Amplify libraries in our project. In order to use Amplify libraries, we need to initialize the Amplify libraries and add the plugins that we're going to use. We're going to use AWS API plugin and register our models to work with the Amplify library. Now let's create a safety chat object. Let's create a safety chat object. And we're going to use amplify.api.mutate function to create a safety chat object. Let's run the project. Let's quickly create a safety chat. Great. Safety chat. Our safety chat has been created successfully. Let's quickly see. So this is the DynamoDB console. If I quickly refresh, I can see a new safety chat has been created here. And you can see the details which are available here. Now let's jump to see how query is going to work. we are going to use amplify.api.query function to request the list of all the safety hash chars where this predicate applies. And in the predicate, you can see that owner is me. Let's quickly run this project again. If I do, I'm able to see all my safety chars which I have created. This was a quick demo on using Amplify library for CRUD operations for your objects. Another key component that we integrated within Energy Queensland application was authentication. We wanted to integrate with their internal user management system, and Amplify provided an easy and quick way to do that. For this demo, I'll be integrating my demo safety chat application with Google Sign-In. Let's start with Amplify Add Auth command to create the AWS resources for user authentication. Let's run the command. We are going to use Google Sign-In, so I'm going to choose default configuration with social provider option. I'm going to choose username to be able to sign in, and I don't want to add any additional changes. We can go with the default domain name prefix. We are going to add a redirect sign-in URI, which we are going to set in the iOS application later. No, we don't want to add another redirect sign-in URI. I'll keep it same. And no, we are going to choose Google. Now I have added my authentication settings to my Amplify backend. It's time to push the changes to AWS backend. Yes, I want to continue. This is going to take some time because it is going to create all the resources. So it is going to take some time. Let's wait for this to finish. The backend configurations have been pushed successfully and all the resources are generated in our AWS environment. Let's go to the AWS console quickly to check the resources. As you can see here, that authentication category has been added to the Safety Chat Amplify application. A Cognito user pool has been created and attached to the Amplify application, and I can actually go to Amazon Cognito portal to see the user pool. And this is the user pool which has been created by Amplify CLI. Next step is to make the changes in our iOS application to use the Google Sign-In. This is a code snippet from AWS Mobile SDK if you're going to use that instead of Amplify libraries. And this is how Amplify Auth API are used to invoke a sign-in session with a social provider. Integrating with social providers is a two-step process in terms of setting up the backend. We only completed the setup required from our backend via Amplify CLI when we set up the authentication. In order to use Google Sign-In with our Amplify backend, we also have to generate an auth to client under Google API settings, which I did separately. I won't be going into the details for setting that up due to time constraints. Once the OAuth client is set up, a Google App ID and secret is provided, which we then add to identity provider setting under the AWS Cognito user pool settings. This then completes the process, and we can now use Google Sign-in in our iOS application. If you recall, we had provided redirect URIs while setting up authentication in Amplify CLI. Those redirect URIs are needed to be added as URL scheme in our iOS application. So that Google Sign-in web views can redirect back to our iOS application after sign-in process completes. The URL scheme is added here. We also need to register the AWS Cognito plugin during the initialization process of the Amplify libraries. Now, let's add the sign-in with Web UI method to log in with Google Sign-in. Amplify provides sign-in with Web UI method, and you can specify the identity provider, which is Google in this case. Let's run the project. Now this is going to redirect us to Google Sign-in. Here, I'm just going to use my credentials. And I am signed in successfully. And now I will be able to create my safety hash shares and view my safety hash share. This is how we integrate with Google Sign-in. Time flies very fast. In this short session today, we looked into Amplify CLI setup, adding APIs, and then integrating those APIs with iOS application, and adding authentication to our backend using a social identity provider. I've barely scratched the surface of what Amplify, along with other AWS services, can do. There's a lot more that we dealt with in the Energy Queensland project, and more that Amplify can do. And that's the end of my talk. Thank you.